κάνεις καλά. Να κάτσουμε μια ώρα και πάμε που θες. Δεν έχω, τώρα ξεκίνησα. Εντάξει, thanks. Πότε? Εντάξει, thanks. Στο Φώτη. Δεν ξέρω, δεν πρέπει να είναι και πολύ ώρα. Τι θέλει να κάνουμε για το ταξί? Τα είδες τα αυτοκίνητα που σου στείλα? Κοίταξε τα, το έχω στείλει στο Facebook. Εντάξει. Στο τρένο δεν θα πιάνει. Πάλι δεν πιάνει πολλές φορές. Δεν ξέρω, κόβεται το σήμα. Ναι. Την ξέχασες?
Για ένα ανέβανε πάλι.
Πού?
Πήρα τα γράμματα τώρα.
Όχι, ένα λεπτό.
Τώρα δεν τη χάσουμε.
Δεν τη χάμε. Κι άμα δεν είναι εδώ, τι κάνουμε? Hi. Good. Ήταν έξω.
Πάρ' τη ζέστη.
Τώρα άστην εκεί, δεν τη χρειάζεται. Πιο μετά. Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. We're going to be flying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport, runway 1449, Lszh localizer, landing surround in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and microflight simulator X. I'm going to start showing the cockpit instruments, the displays and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure above the barometric altitude above the sea level, and also the barometric pressure with inside atmosphere, the target altitude selected from the autopilot and flight director system panel, the vertical rate of climb descent of the aircraft intense heights as we remain at all the signals of trigonometric angles increase can climb descent. We have also the artificial horizon with the altitude indicator, the pitch ladder decrease and the bank angle decrease. We have also the Lszh localizer, the instrument landing system with the threshold antennas of the runways we use for takeoff and for landing. The transmitter radio frequency we receive from the onboard antennas of the aircraft, so we can align with the horizontal localizer and vertical glide slope. We have the ILS localizer, unique radio frequency for each runway, and magnetic north pole heading we use for takeoff and for landing. We need to tune the ILS localizer for this specific runway. So we have the runway 14 over here. You can see in Zurich International Airport. We're gonna use both for takeoff and for landing. Also we have the ILS localizer crossbus. We have the angle of approach, the glide slope, and we have also we have the angle of attack of the aircraft as it flies in the fly mode and non-zero with the autopilot and the auto throttle. Later on vertical navigation modes. We have also on the HSI that displays the magnetic heading and track. Also displays the flight plan we create. So we have the flight plan created using the flight management computer. It's gonna show us the purple from a zeta line. So we're gonna input all the waypoints one by one over here. Using the flight management computer, you can see here will be displayed in the navigation display, also in the HSI from the integrated display of the flight plan. So we have the navigation display that displays the GPS position of the aircraft, the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. We have the terrain and weather reflections from the weather radar. You can see the red, green, yellow amber indication of the terrain around you, or also in front of you and below you when we fly. So depending on the distance of the terrain away from you, and also the vertical altitude above the ground, you can see different terrain colors like red, yellow, green, and amber. And we have also the navigation display displays the terrain map, the airports. You can see also the sea displayed with blue, the lakes and the rivers. We have also the airports with a 4-letter name. We have the runways and the taxiways we're gonna use for takeoff and for landing. The runway length and the runway heading. We can see the navigation display, and also we can see other airports where they allocated the distance in nautical miles. We have also the other aircraft. We have also the navigation aids, the nav aids that display the workstations, ADFs, and DPs. Also the waypoints, which are horizontal and vertical navigation fixes in altitude and airspeed constraints. We're gonna select some waypoints for the flight management computer. So we're gonna create the flight plan. You will see it displayed in the navigation display in the horizontal and vertical profile of as we find. Also the navigation display displays the other aircraft using the transponder, the ASP and ADC transmitter receiver that transmits a radio frequency to other aircraft and the air traffic control, and receives from other aircraft. Can make calculations with its computer about the other aircraft distance from our aircraft and bearing distance and heading from our aircraft in nautical miles. We can see aircraft up to 40 nautical miles using the transponder and the TICA system, or 72 kilometers in a 360 degrees radial. So we can see also the altitude difference between our aircraft and the other aircraft, how many hundreds and thousands feet are above or below us. Also you can calculate whether the other aircraft climbs or descends with respect to our aircraft. You can calculate the velocity closing in between our aircraft and the other aircraft. It gives us a warning. From the TICA system, we have an incoming collision in the air with another aircraft, so we'll make an avoidance maneuver. You will see also that we have also the TICA system will display the other aircraft with the diamond shape. You will see in the navigation display. Also we can see other aircraft when we are in the ground, in the airport runways and taxiways. So we have the TICA system, traffic collision and advisory system. So you're gonna see also the autopilot flight director system panel, the auto throttle, the ACAS, the engine indication control system display, the flight controls. So I will show you all systems of the aircraft of the Boeing 787-900 aircraft before we go into a full manual flight. In the end part of the video, I'll make an engine start demonstration. Before that, I've set up the flight management computer and the autopilot. So I will show you all the flight controls and the thrust levers, the engines function, Also the flight control computers, what they do in the aircraft when they fly. So you can see here we have the flight controls. I use the side stick to control the aircraft. I have also my computer here and the mouse pad, so I can input all the data I need. When I use the flight management computer or the autopilot, the switches or the overhead panel, and also the horizontal trim stabilizer, I have these switches mainly, so we can use the side stick over here for climb descent. When climbing, we use also, you can see it moves the yoke, the control column of the Boeing 787, so we can climb and we can descend using the control column of the Boeing or the side stick of the Airbus. Also we can make turns to the right and turns to the left. You will see the side stick moving left and right. We can have the control wheel over here, right or left control. Also we have the rudder pedals. You can see the rudder pedals that move the rudder, the vertical tail stabilizer rudder, and also the nose wheel steering, so they have a double function. We have also the tiller for the nose wheel steering, and also the rudders, we have the toe brakes, so we can use full flight controls like this, coordinated flight, move all flight controls together. So I'm gonna show you also the outside view of the aircraft and explain you So I will talk to you now about Newton's physics and the Bernoulli of fluids, about aerospace engineering, and also aerodynamics of flight. We need to know for the air transport pilot license and the commercial pilot license, the aerodynamics, flight dynamics, and the principles of flight for the Boeing 787. So also the outside view, and I will explain you how the aircraft flies. You will see it later also in the air when we apply all these functions, also using the flight controls here, the side stick you can see, those are the same 3D. So we go over here, you can see the outside view of the aircraft. So you can see the wings of the aircraft hold the weight of the aircraft when it's flying, the surface area. The weight of the aircraft is divided over the surface area of the wings over here. So we have also the weight, the lift produced from the wings overcomes acts over the weight that comes down over here. So the aerodynamic flow of the airflow below, we have higher pressure below, which pressurizes the wings up into the air, and we have lower air pressure above the wings, which sucks the aircraft wings up into the air. So this creates the lift. Also we have the thrust component, the jet blast from the engines. So this is a jet aircraft. So the thrust overcomes the drag and the lift overcomes the weight. So we can see here we have the jet engines. You can see we have the high pressure compressor and turbine over here, the high speed starter and shaft. So we have also the combustion chamber over here. We have the fuel lines over here that supply from the left and the right wing over here, as you can see, left and right wing, and we have the fuel flow to the engines over here, the low and high pressure fuel valves and the fuel booster pumps. So we have the fuel tanks over here, right and left wing fuel tank and the center tank to feed the engines. So also in the engines we have high pressure compressor and turbine, high speed starter and shaft. We have the low speed starter and shaft in the front, and the low pressure compressor and turbine, and the front fan. The front fan is this front plates in the front that also supply the bypasser. You can see here this opening in the back. It's the bypasser from the front fan for the jet engines. We have the high pressure compressor, also the jet blast from the exhaust from the combustion chamber, which is has different airflow speeds. So we have also, so this is the explanation about the engine. We have also the wing and engine anti-ice, and the flow of hot air for the wing and engine anti-ice over here. So we have also the aerodynamic cord over here, 23% of the Mach, where the maximum aerodynamic lift occurs in the forward wings. It's also where the center of pressure acts back and forth when we fly. Also, the airflow becomes detached. We have the stall of the wings. When we fly for a given angle of attack and airspeed that changes, increase or decrease. So we need to monitor here when flying. We have the primary flight display over here. You can see we have the airspeed indicated over here. Right now it's 30 knots, but we're not moving. Minimum airspeed indicated. We have also the altitude. So you can see here when we're flying in the airspeed, you can see the airspeed indicated. The stall speed is gonna be given with a number and red line below the airspeed when we fly. Also, you're gonna see the angle of stall. So if we stall, we need to apply the stall avoidance. In the Airbus, you pull the side stick down. In the Boeing, you push the yoke forward, and you apply more thrust to increase the airspeed after you decrease the angle of attack. Maybe you need to apply some rudder pedals also. So this is a stall avoidance. We need to know to avoid stalling the wings of the aircraft when flying. So the mean aerodynamic chord, we have 30% in the left and the right wing, 10% in the center. The mean aerodynamic chord, this is where the center of gravity is located over here. So the center of gravity of the aircraft is used for controlling the rudder deflection. So we have the yawing axis of the aircraft like this. We can yaw left and right the aircraft. So we use the rudder pedals to yaw the aircraft in the air or in the ground like this. You can see left rudder, right rudder. Also nose wheel, left nose wheel, and when we are in the ground in lower speed, right nose wheel. You can also apply the tillers for the nose wheel. Also the top brakes, we can press the brakes if we press the top surface of the rudder pedals. So we make left and right turns like this. I have the side stick. In the air, also in the ground, lower speed, we have the nose wheel, the forward nose wheel from 0 up to 45 knots or 72 kilometers an hour. We can deflect the nose wheel 76 degrees, either left and right. Turns using the rudder pedals, so the tiller, also the rudder pedals move together the rudder at lower speeds and the nose wheel. So at 45 knots or 72 kilometers an hour, the rudder becomes aerodynamically effective. So the nose wheel deflection will decrease from the computer automatically. You don't need to do nothing to that. From 76 degrees to 7.6 degrees, like for takeoff. So we have the rudder aerodynamically effective. After that, then as we increase the airspeed in takeoff, the forward nose wheel at around 80 nautical miles per hour or 144 kilometers an hour from the computer would be automatically locked to 0 deflection, or like a small deflection like 0 or 1, 0.5 or 1 degree, half or 1 degree. So we have only the rudder aerodynamically effective above 80 kilometers an hour, 80 nautical miles an hour, or 144 kilometers an hour in takeoff. So all this is done automatically from the computers of the aircraft. You don't need to think anything to change the deflections of the nose wheel or the rudder. All the limits is automatic when flying the aircraft. So we have on the rudder above 144 kilometers an hour or 80 knots. Also, when we take off about 250 kilometers an hour or 140-150 knots, we have on the rudder. Also, when we land at the same airspeed, about 250 kilometers an hour, 140 knots, we have the rudder first. Then as we're slowing down, we apply the brakes. Then the nose wheel comes active again to a small deflection, then increases. Is the inverse from takeoff. So I will show you now. So this is the rudder pedals control, the rudder and the nose wheel, as you can see. So I will show you now one more axis. Here is the from wingtip to wingtip. In the Airbus the pizza axis, and the Boeing also is the side stick over here, as you can see, back and forth like this. So we climb and we descend back and forth. You take the weight of the aircraft up, you climb, and you take the weight of the aircraft down, you descend using the elevator. Very easy, very simple. You don't feel any weight actually in the side stick. So we have this is the pizza axis in the Boeing aircraft also. In the Airbus is the side stick back and forth. In the Boeing is the yoke back and forth. So the Airbus is more easy maybe than the Boeing. So we have also over here you can see the side stick, pitch up and pitch down. So you take the weight up, you climb, you take the weight down, you descend. So this is both fly-by-wire aircraft. You don't feel too much of weight either in the Boeing now, in the Boeing 787 or 777. Besides the fly-by-wire system, it has the flight control computers to actuate the flight controls when we fly, like in the Airbus aircraft. So this is climb and descent, and also we have one more axis, it's the longitudinal axis. You can see we can make in the Airbus left and right turns using the side stick. Very easy. You turn the ailerons and the spoilers in the Airbus to make aerodynamic lift difference between the left and the right wing, and make turns left and right like this. Very easy to apply. Also in the Boeing you have the ailerons, the spoilers, and also the flapper on one more surface for controlling the turn. Very easy, they're all turn. You apply also the elevator for climb descent and the rudder, all flight controls are together, coordinated flight. So we extend the spoilers, we have also the flaps fully extended as you can see, and now the slats. So in the Boeing you have the control wheel left and right like this. In the Airbus is the side stick left and right for making left and right turns. So very easy to remember. We have all flight controls together, coordinated flight. Also in the Airbus you have the side stick priority. You can take priority for either side with the side stick, or you can have dual input together. Like in the Boeing you have actually coordinated inputs are interconnected, so they move together. There is no difference between the left and the right side, the captain and the first officer, unless you apply more force in the yokes of the Boeing aircraft to override the other side, if you have failure for instance. Also the rudder pedals, both in the Boeing and the Airbus, are interconnected and move the same deflections. So we have also the horizontal trim stabilizer over here, and here the alternate. This is the normal, this is the alternate, and this is the cutoff switch for stabilizer trim. I have it here. The Airbus also has autopilot disengage here and the push to talk button. I have the thrust control also here. You can actuate the thrust levers using this control. You can see the thrust moving back and forth here. So we have here very quickly, I will show you. You can see here we have the horizontal tail when we climb and we descend. Also we can apply the horizontal trim stabilizer. We can trim the horizontal tail for convenience, make more easy the fly. We have also the auto trim. The aircraft has its computer, flight control computers, and trims the tail surface automatically, like in the Airbus and the Boeing. So we can apply the horizontal trim stabilizer over here, as you can see. So this is the horizontal elevator trim for the Boeing 787, also the Boeing other Boeing aircraft like so you trim the elevator up, you trim the elevator down. You can see so you can see elevator over here, and you can read the tag better. Yeah, you have it with a clear view. Elevator, left click down, right click up over here. So this is what the tag reads: elevator, left click down and right click up. So you trim the elevator switch down, you pitch the nose of the aircraft down. When you fly, you trim the elevator up, you pitch the nose of the aircraft up. So this way you trim the elevator up, this way you trim the elevator down. So you pitch the nose up and you pitch the nose down. Very easy, quite convenient to remember, very important. Elevator to trim, left click down, right click up. You can see we have the flap speeds here also. We have the head up declutter and the autopilot disengage over here. So we have the alternate. This was the normal channel. We have the alternate channel of the flight control computers over here for pitching the aircraft. So we can apply again. You can see the elevator trim, left click down, right click over here up. So this way again, you pitch the nose of the aircraft up, you trim the elevator up, you pitch the nose of the aircraft down, you trim the elevator down. It's very easy to remember like this. And also we have the parking brakes, as you can see, apply, and also the stabilizer cutoff switch. I will talk to you now. This is to cut off the function of the auto trim channel of the flight control computers of the hydraulic system for the elevator. So we have here, you can see how many degrees we pitch the nose, the stabilizer. We trim the stabilizer up and down. Over here now is in the green band for takeoff, nose up and nose down. Also the rudder trim over here. You can see the flaps also that we're gonna use both for takeoff and for landing. Flaps, rudder trim, the cabin pressurization. We can see other things over here in the screen. Landing gear, extended track down right now is extended. Standby instruments, the engines, left and right engine indications. I will talk to you now, displayed from the far right. So you can see the rudder, the stabilizer trim over here, horizontal trim, and the cabin altitude. When we climb with the same, we see the outflow valves open to depressurize the cabin and close, pressurize the cabin. Also climb descent, pressurization, depressurization, differential pressure 7.8 psi when we climb the maximum altitude, landing altitude. So the cabin altitude will go to 6,000 feet when we climb the aircraft to 43,000 feet. The cabin pressure is gonna be same like 6,000 feet altitude or 7.8 psi pounds per square inch. Gross weight for takeoff, total fuel aboard. Also you can see some more features here. The landing gear, alternate gear over here, lock override, so alternate gear. The auto brakes over here, rejected takeoff. RTO, we will display RTO here, rejected takeoff or disarm. And also when we land, we have the auto brakes at 1, 2, like this. So we can see also the flaps position and the speed brakes position. So we have the flaps lever, very important, increase or decrease the surface area of the wings. You can retract the flaps like this or extend them to position you like. Also the thrust levers, forward and aft. So we have the thrust control, left and right engine, The auto throttle disengage switch. This is disengage. You press this switch, disengage the auto throttle, take off, go around, thrust reverse, speed brakes over here, external retract, fuel control to the left and right engine. Also fire extinguishers for the left and right engine, pull out and switch, the transporter, radio communication panel, high frequency radios, satellite communication, ground proximity, the radar trim over here, the switch. So you can see it says weather, satellite, weather radar. We can tune the frequency for the air traffic control, for the control tower, for takeoff and for landings. So continuing with the horizontal trim stabilizer over here, we trim the manual like this, normal alternate channel over here. So we have the cutoff switch. We have a failure of the flight control computers because we have the normal, the alternate and the direct mode of the primary flight control computers. This is a fly-by-wire aircraft, so we can see the hydraulics. If the hydraulics fail, we have a failure of the hydraulic system. You can see the pumps, the left and the right engine, primary and demand, and electric, the running turbine. So this is a fly-by-wire aircraft. It has flight control computers. It can trim itself automatically in flight if we have a failure of the flight control computers, and the modes of the flight control computers gonna be degraded from normal to alternate or direct or mechanical backup. We can have to disconnect in some cases, like in the direct or mechanical backup, disconnect the stabilizer trim, cutoff switch from normal to cutoff, because we're gonna have failure of the hydraulic system, and the autopilot will be also inactive. So we're gonna have to fly manually and also trim the aircraft manually. You can see the hydraulic system here. So the horizontal tail, the elevator maybe won't function for the trim system like this. We need to come down here. The primary flight control computers will be degraded. We come down here, and this is for all Boeing 737, Boeing 747, Boeing 757, Boeing 767, and Boeing 777, and Boeing 787 aircraft. You open from normal to cut off these switches, the L1 and R2, either one, left or right horizontal trim stabilizer, or both. You can read the tags from normal to cut off, and use only the alternate pitch stream of the manual pitch stream over here. So this is from normal to cut off, the stabilizer trim. You can see cut off, and use the manual trim switch over here all the time when flying. This is similar like the Embraer aircraft, this system, trimming up and trimming down. So you can see again, elevator trim, left click down, right click up, with the alternate trim switch, also the CRJ. So we have the flight control computers when we fly. In the Airbus aircraft, you can see we have the side stick deflection, left and right is limited to like 2.8 Z or 1 Z. 1 Z is the acceleration of gravity. So in the Airbus, the side stick deflection left and right turns is 67 degrees or 2.8 Z, with the side stick fully deflected, or with the side stick release 33 degrees. You need to again turn the side stick to apply the flight control computers to make lever flight or change the angle. So when we climb also, we have 30 degrees in the Airbus, or 1.5 G for climb limited, and when we descend we have minus 15 degrees or minus half G in descent rate. So we have also the angle of attack, the stall, the alpha protection, and 1 Z stall angle of attack, lowest speed and high speed protections. So the Boeing has similar features for the flight control computers. So we have also the side stick. You can see the flight control computers. So I will show you one more view of the aircraft flight controls over here. And then I'm gonna set the flight management computer, make an engine start demonstration also. So we have a few more minutes for that. So you can see we have an aircraft coming in for landing like this. Very nice. The Boeing 737-800, as you can see, we just spotted. So you can see how fast it's going. That's down. So just that's now, as you can see. So we can see here a few more things. We need to know one more view of the flight controls of the Boeing 787. Also the side stick. Then we go for the flight management computer and the rest of the systems. Make an engine start demonstration and complete flight. So now you're gonna see the view of the side stick again over here. That is identical to the Airbus side stick. So hope you like how I use all the side stick to control the yoke of the Boeing 787. You can see very easy. Climb and descent, side stick back and forth, and also make turns right and left. So this is the fly-by-wire aircraft system. So we can make turns left and right, side stick deflection, climb and descent, very easy. With the Airbus also control the same flight controls in the Boeing aircraft. There is no difference in the control feeling when flying with the yoke or the side stick. So we can apply also the thrust commanded here from the engines. You can see the percentage. Also the horizontal trim stabilizer over here. So we can trim the horizontal tail up and down. So you can see the side stick deflection is proportional to the yoke deflection when climbing and when descending. Make turns to the right, make turns to the left. Also the captain and the first officer flight controls are interconnected and move together in flight. Also the outside view. So we climb, we descend, make turns the rudder left and right. Very easy, climb, descend, the elevator. And also the ailerons and the spoilers like this. Left turn, right turn, very easy. You see the ailerons and the spoilers moving. The elevator, climb, descent, and the rudder. So now I will show you the flight management computer over here. So that was enough for the flight controls. Now I will show you the mousepad and the keyboard I used to input all the data in the flight management computer. So now is the turn of the flight management computer. We can input all the data we need for this flight. Also create the flight plan. The autopilot flight director system panel is gonna follow in flight. If we command the autopilot, so we go here. So we go here and this we can see first this view. So we have the mousepad here, as you can see, the touch screen, left, right, electronic flight bag, lower, and the screen here, the index. So we use identity, position, performance, takeoff, approach, annunciate status, flight plans. You can see also we have the keyboard functions here and here, and also the keyboard, the line select keys. So We go over here for this view right now. Control quadrant. So we start with identity position performance. Identity is Boeing 787 GNX engines aircraft. We continue with the index over here, the position, the Lszh airport, Zurich International Airport, the coordinates of the position, so we can align with the IRS, Universal Reference System. The performance, 0 fuel weight plus fuel on board. We have the gross weight for takeoff, fuel and weight calculations, reserve fuel, cruising altitude, cost index, fuel freezing temperature, and the center of gravity in flight. So we continue with the route over here at Lszh, the departure airport, destination airport here, copy paste, both sides, clear, and use the runway 14 over here, departure arrivals. So we have departure. We can use either runway 10, runway 14, runway 16, runway 28. So we use runway 32, we use runway 14 and select Zui to Alpha. The seats, the southern instrument departure waypoints and fixes, departure arrivals again. Select the arrival, VOM 16, the approaches of the runway 16, 28, 34, 14, ILS 14, ILS 16, ILS over here. 28 ILS 34, GLS 14, localizer 12, localizer 34. So we can use ILS 14, Transamity, its transition waypoint and starter terminal arrival waypoints and fixes for approach and landing, align with the runway and the ILS localizer. So we have the route over here is created and displayed with blue, is not yet active. So we have the first waypoint of the takeoff, climb to the Zui, make turns left and right, descend, approach Zurich 701 and landing in the runway. So we use the initialize, 0 fuel weight plus fuel on board, gross weight for takeoff, reserve fuel 5%, cruising altitude 35,300 feet, and the cost index 100%. Fuel freezing temperature, I'm gonna say minus 37 degrees, and the center of gravity. So the fuel freeze in flight. We have the legs here. We press the execute button. We'll activate the route over here. We saw as purple and white. So we have the first waypoint, 136 heading. So this is the flight plan with autopilot. One waypoint by another is gonna follow if we connect the autopilot in the LNAV navigation. So we have 250. The airspeed 1900, climb, make left turn to the Zui, 6 nautical miles, 301 knots, 6000 altitude above the sea level. Nigria 071 heading 26 nautical miles for Zui, 301 knots, airspeed, flight level 22,200 or 7,000 meters. Then make a right turn, 12 nautical miles from Nigria, 230 heading, 320, 11,800. Descent 6 nautical miles, 9 Amity Zui, Zurich 701, 6 nautical miles, 180, 6,000 alpha. Then TRA CY14 Osnem, make a left turn over here, left turn for alignment with the runway, 8 nautical miles, runway 14, approach and landing, the airspeed and the altitude. So we set the flaps for takeoff, center of gravity, trim 33%, 4.25. The takeoff speed V1, V0, V2, gross weight for takeoff. We have departure arrivals, alternate VNAV, progress, FMC communications, hold, we can hold over a waypoint in flight. The fix, set a fixed radial, also navigation radio. We can tune ILS and VOR localizer, IDF. So we go back to the legs. I'm gonna be using by the autopilot over here for flying. So we can see we have the airspeed, as I'm telling you, indicated. Barometric altitude above the sea level, the vertical rate of climb descent of the aircraft, 500, 1000, 1500, 2000, 3000, 6000 feet. This needle will move up when we climb and move down when we descend. So we have the pitch ladder decrease, 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 2 degrees for pitch up and pitch down as we fly. The level wings of the aircraft, wings level, also the bang roll. You can see how many degrees: 5, 10, 20, 30, 45, 60 degrees for making turns left and right. Also the flight director crossbars, the airspeed commanded by the autopilot, 210,000 feet, the altitude commanded. So we have the radio altitude right now is -2 feet. It can be like 2,500. You can see the flight plan now we created here, and here is displayed in the horizontal. Also you can see here is the Düsseldorf, the airport, the DTL in front of us, 60 nautical miles. You can see 40 nautical miles here, 80 nautical miles. You can set the scale and the degrees, the view, also the vertical when we fly. So the barometric altitude here for the barometric pressure, flight director on, is 29.92 inches of mercury over here. We set using the FS panel 29.92 inches of mercury over here, 1013 hectopascals. Right now we can increase and decrease the altitude displayed by increasing and decrease the barometric pressure, radio bar, also plan rates, weather radar, traffic, terrain on the display, accept, cancel, reject some warning system, CDU info, checklist, communication, navigation display, engines display. So we have the navigation display, the engines indication. Also we can see the map over here. If you look a little bit closer, the waypoints we have to fly, the runway. Also the runway is displayed in front of us. You can see the taxiway. This is the taxiway displayed from the GPS. Also the runway we're gonna use for takeoff and for landing. Also from the outside, source, from the weather radar reflections. You can see the terrain when we fly. So this is the runway, the taxiway, the whole airport, view of the Zurich airport, runways over here. So we can have further away also the terrain in front of you when flying. You will see the mountains in front of you, the distance, 5 nautical miles, 10, and the altitude we're gonna be flying. So this is the aircraft symbol. We need to climb and fly through these waypoints, actually this way. So this is the approach side. So we have also this view also very quickly. You can see the aircraft symbol over here. This for navigation purposes, map setting, the elevation of the terrain, 2,700 feet, south, northeast, west. So we have over here further away, you see more airports. So you can see the Germany, Switzerland over here. So this is Germany, France over here, and the Switzerland down here, these areas. So we look closer. We need to go for flying the aircraft very fast. So we have a few more seconds left. This is we're gonna start the engines using the APU for making an engine start demonstration. Also the lights over here. So we have the left and the right engine driving IC 100 to 200 volts for 100 hertz frequency, 130,000 kilovolts. Left and right engine driving, batteries, APU generator, primary flight control computers in the auto position, air data computer over here, flight control surfaces, also GPS receivers, other things, the battery, tailwind power, FT door, passenger oxygen over here, window heat, rammer turbine. You can see backup hydraulic, left and right engine driving, electric C1 and C2. So we turn off. You will see the faults are displayed, and also start the engines back to the on, engine driving, hydraulics. So we have also the wing and engine ADIs over here on an auto position. We have the cabin pressurization here, outflow valves in the auto position. We use the outflow valves to climb, pressurize the aircraft. In the auto we need to do nothing, it's automatic. So we have the pressurizer from the engines for cabin pressurization, oxygen, wing and engine ADIs over here, and also pressurizing hydraulic fluid tanks. So we have also the recorders over here, the cargo and APU fire over here, the engine control, electronic engine control, normal start modes, normal and alternate modes. So we can start the engines like this. This controls also the farex, the fuel jettison. We can dump some fuel if we arm this and select the nozzles and how much to remain. And also the fuel pumps, left and right wing, center tank, The crossfit valve will turn it on, interfeed either engine with other pump and balance the fuel between the left and the right wing, right the tank. So fuel booster pumps back on. So this is all the systems we need to see in the overhead. We have more view from the displays over here very quickly. So we go over here, the systems display, you can see what it displays. The APU is running, hydraulics, over here oxygen and liquid cooling, quality of the oxygen, the electric left and right engine driven, electric APU generator, the load set, the batteries, voltage, start and discharge 31 volts right now. So we have the hydraulics, where the hydraulic fluid goes, which systems use hydraulics, left and right engine driven, electric C1 and C2, set of valves and isolation valves, also the pressure 5100 psi in the quantity of hydraulic fluid. We have the fuel on board, the fuel tanks. So you can see we have the minimum fuel temperature down here. It says minus 37 degrees and minus 6 is the temperature of fuel right now. So below it, when flying high altitudes, the fuel will freeze, so the FADEX recirculate the fuel automatically from the left and the right wing, and the center tank we have the fuel transfer for heating up the fuel from the FADEX automatically. We don't need to do nothing. Also the lubricant and the oil. So we have the fuel tanks here, you can see on the left and right wing, and the center tank we have 11,000, 11,000, 11,000 total 33,900. We have the Lszh high pressure fuel valves feed both from the center of the left and right wing. The crossfit valve is off, but we turn it on, it will feed either engine with other pump or either tank. Also the APU favor from the left wing using the DC motor over here. So this is how the fuel management, the air pressurizer for oxygen, for cabin pressurization, hydraulic fluids. So doors are closed, the cabin can be pressurized. The gear, you can see the pressure of the tires and the temperature of the brakes. Flight controls over here, making left and right turns. The rudder, climb, descent, rudder and elevator and stabilizer trim. So this is one of the last things we need to see in the Boeing 787 before going into flight. So we have a few more things to check. IFF is display over here, status, maintenance over here, systems, circuit breakers. So systems menu, we have also the checklist, like we need to do before start, after start over here, after takeoff, descent, approach, landing. It's the full checklist of the aircraft, and also the procedures. So we have communications, navigation display back for starting up the engines very quickly. Need to turn off both engines. Fuel control in the off position like this. So see what happens when you turn off fuel control. You can see the fuel pumps and the engines. So we look outside. You can see the engines are going off. So we need to restart them. You will see how we do an engine restart over here. So we're going in the overhead very quickly. Turn both in the auto start position, the engine control. And we have the configuration yellow switches in the overhead and start the engines. So now we have only pressurizer from left and right, from the APU actually, into the N2 stage to start the engine starter. There is no fuel yet. So this is the N2, which is a high-speed starter, high pressure compressor and tube, and with the turbofan tube, which is engine. We have also the N1, which is a low-speed starter, have low pressure compressor and tube, and with the turbofan tube, which is engine, exhaust gas temperature, fuel flow per engine per hour. So we start, you can see pressurizer. We start the fuel flow above 20% like this. So you see fuel control in the on position. So the auto start turned on above, but we have both fuel and pressurizer for the engine starter, oil pressure, temperature, quantity, and the vibration of the N2 stage of the engine. As you can see, all the stages, vibration, increase. So we have 51% over here. The engine's almost start. The message is going off, and we're gonna have at 60%, 62. The engines are running with a green message, so we use flaps for takeoff over here, speed brakes in the arm position, only the autopilot here. Very quickly, so you can see we have the LNAV, the VNAV now, flight director off, we turn off the modes, so we have the auto throttle left and right like this, on and off, autopilot disengage, so we set the airspeed, nautical miles per hour, the heading, bank angle and heading, we're gonna set the heading of the runway for takeoff 136 degrees. So we set the vertical speed, zeros, descend, you see the minus sign. When we descend or climb, we go up to 3,500 feet for this. And also we have the altitude thousands, like this, and hundreds, turn the switch. So we can go for takeoff like this, parking brakes off, we take the clearance from the air traffic control, advance the thrust levers. So advance, align with the runway, set a line over here, you can see the runway is open, there is no other aircraft coming in. So we align with the center line, we go into the runway position. Σε 18 λεπτά είμαι έτοιμος, 18 ακριβώς. Εντάξει. Advance the thrust levers. Μην βάζεις τώρα τη ζέστη, βάλει την εσύ. So we go for takeoff, advance the thrust levers. And also push the side stick down, the yoke in the Boeing. So at 80 knots, release the side stick of the yoke. So we have 80 knots, 100, 120 V1, we rotate slightly like this, 9 degrees, align with the rudder pedal now, and we have the pitch climb, as you can see, 9 degrees or less, so we won't strike the tail of the aircraft into the runway, both in takeoff and in landing. So you can see we climb, we have a positive rate of climb, landing gear over here up, retracted. Also we can see the displays very quickly. We have 15 more minutes. So you can see the airspeed indicated 200 knots. We are 1,700, 1,900, 2,000 feet above the ground, but 3,500 above the sea, 2,400 above the ground, but 4,000 above the sea. We climb with 5,900 feet per minute. The pitch altitude here, the stall speed. So you can see the wind over here, direction, the terrain in front of us and below. We can turn it off like this. You can see a little bit in the terrain mode. You can see red, green, yellow indications here. Also, if we look closer, you can see the flight plan again. You can see we are having the terrain with the green around us and below us. We are 4,000 right now. Feet, 4,800, 900, 5,000 feet above the terrain over here. So you can see this green line, this green wave below us is the terrain, and the aircraft is 5,400 feet. It keeps climbing, as you can see. We need to avoid the terrain as we climb. Also you can see the stall speed, red and yellow indication. So the terrain awareness also. If we look outside, we need to start the turn now. We have the runway will depart, the view of the Switzerland. So hope you like this view. So we start turning right now using the flight plan. So we use manual flight controls. Maybe not have time to use the autopilot in this flight, but that's okay. We're gonna make a manual flight. So we keep climbing, as you can see. So we are lying over here, also a bit less clutter. This is the waypoints. So we have a beautiful view over here, the Switzerland, as we keep climbing. Could be like this view of the aircraft of the Boeing 787. Keep climbing, and we have a few more minutes, as you can see. So this is a beautiful view of the Switzerland, Zurich, the galaxy, the terrain around you, the Germany, my homeland, in front of you, and this France. So keep climbing and have a few more minutes. Over here we need to align with the flight plan, make a small turn as we keep climbing. So this is the view of the cockpit just after takeoff of the Boeing 787. The overhead panel also. Look around you. So we have all the air data. Here we need to fly the aircraft, make a small left turn over here, and then a right turn. So you can see the stall speed is displayed with the red here is 125, 130 knots right now. For this flap setting, this altitude as we make small turn. We are 17,000 feet above the sea level, climb 3,000 feet per minute, the pitch altitude and the bank roll. So the stall speed is very close. We have also the wind direction, the flight plan we need to follow over here. You can see the Zui, and also we have the engines over here indicated as we fly. Also the flight plan here we have created the flight management computer. We need to make changes the autopilot. So we align with the flight plan here. This is the LNAV. Now we're gonna have the LNAV connected over here. Follow the lateral navigation of the aircraft as we fly. Use a bit right rudder for the turn. Make it faster, more coordinated. Maybe we need to slow down the rate of climb. We have reached the altitude of climb, and we have 9 more minutes left for this flight. As you can see, 20,000 feet. So maybe we can connect the autopilot if we need. You will see how the auto throttle left and right, autopilot on, second, and decrease the rate of climb like this. So now we're flying with the autopilot connected. Also we can see the outside view again, and we start the turn very quickly over here. So we have the Switzerland, the lakes, the Germany, my homeland, the Bayern Munich over here. So we go for the turn very quickly, apply this over here, override this waypoint. So we have to fly through this waypoint. You're gonna see we're flying closer like this. This indicates the autopilot. Also flaps up. We increase the airspeed right now. So we make manual turn right now. Disengage the autopilot, we can reconnect again. So now it's flying manually the turn, no problem. For us, maybe faster rate of turn. Use also rudder pedal, right rudder. So this is overflying here the Germany, the Boeing 787, as you can see. Overflying France also, Germany, and the beautiful Boeing 787 view over here. So we need to align over here with the flight plan. We need to level off. Also use more flaps, decrease the rate of climb. Align with the flight plan over here. So this is the alignment of the flight plan. Full manual right now, as you can see. We disengage the autopilot because we need to make a little bit faster some maneuvers over here. Engage the autopilot again. So we apply our maximum thrust right now as we fly. So we have a few more minutes to go back to the airport. So this is the beautiful view outside, overflying Switzerland. The night sky over here, as you can see. The galaxy and the chemtrails behind us. So we leave behind the Germany, my homeland. The lakes, the France on this side. So we need to start the descent now, as you can see. Frozen vapors, and we need to descend back to the airport. So we initiate descent now, either automatic or manual. And now vertical speed, we're gonna use also more airspeed for the descent. So we're gonna have more airspeed, we're gonna descend a little bit faster, like this. You can also disengage the autopilot again by idle thrust. So we keep descending. And we have 4 more minutes left for approach and landing. We need to descend faster, as you can see. Idle thrust over here. Keep descending. Speed brakes also extended. Increase the rate of descent. You can see we flying manually right now. We have 3 more minutes for approach and landing. Perhaps we're gonna make it. So now flying manually over here. As you can see, make the turn. And apply left rudder as we descend. for this turn over here. We need to align now with the flight plan over here to make a steep turn. So we have 2 more minutes for approach and landing over here, as you can see. We need to align now with these waypoints over here, with this flight plan line as we descend. So align with the runway over here component. Let's use landing gear down. Flaps also extended over here. We keep descending, increase the rate of descent for this approach, as you can see. So we have the approach also view over here. We're gonna have the outside view for the touchdown as we are approaching the runway. Apply a little bit more airspeed. So we have the Lszh localizer. We can see all the data we need for the approach and landing over here of the aircraft. So we have a couple more seconds for touchdown. A little bit more thrust. We have some side wing over here, some wing gust, as you can see. So we need to fix the wing gust and the side wing component for approach and landing. So we need to align with the runway. Runway aligned. Few more seconds. So we have the flare of the aircraft over here. So we flare, as you can see, beautiful flare and touchdown. Very beautiful, very professional. So we use align with the runway over here. Parking brakes, idle thrust, and thrust reverse, full thrust reverse. So we're slowing down right now. This is the slowdown of the aircraft.